Hello, today we are going to continue our discussion on negative refractive index. This is the third part. If you have missed the first two parts, please visit my YouTube channel Maxwellians. You will find the link there. Also, I will provide the link in the descriptions of this part. Yesterday, or in the last discussion, we stopped at Maxwell's equation while starting to derive the wave equation and the Poynting vector for a medium in which both epsilon and mu are negative. So let us complete the derivation today of wave equation and Poynting vector and see some interesting consequences of these two. So first, let us derive the wave equation. In the last discussion, we stopped at this point. Omega epsilon E is equal to k cross minus 1 by omega mu k cross E. This we derived from Maxwell's equation. Now with this, what we will do now is multiply on left side and right side with omega mu. So left side becomes omega square epsilon mu E. Right side becomes minus k cross k cross ke. So k cross E is a vector triple product. So that we can use back-tab rule to expand. So that gives us minus k into E dot k minus k dot k into E. Now we know E dot k is 0 because k is the wave vector, E is the electric vector. The wave vector and electric vector are orthogonal to each other or perpendicular to each other. So their dot product is 0. So the first term will be 0. The second term is minus k dot k, which is k square. So minus k square E, we have a minus outside the bracket. So that makes it k square E. So omega square epsilon mu E is equal to k square E, where epsilon into mu, that is n square, n being the refractive index. So n square, n can be written as n plus j kappa, kappa being its imaginary part. If there is a loss, if the medium is lossy, then kappa is non-zero. Otherwise, if it is not lossy, then kappa is 0. And k square is equal to k dash plus I k double dash whole square, or k is equal to k dash plus I k double dash. K double dash is the imaginary part of the wave vector. It is non-zero in lossy medium and it is 0 in if the medium is not lossy. Now look at the equation, wave equation. Wave equation now becomes omega square mu epsilon E is equal to k square E. So on the wave equation for a right-handed material and for a left-handed material are same. There is no change in the wave equation for between a left-handed material and a right-handed material. Now let us come to see what is happening to Poynting vector. So the Poynting vector by definition is the cross product of E and H. So S, the Poynting vector, is equal to E cross H. So that we can write as h, we can write as 1 by omega mu into e into minus 1. So actually this h is equal to minus k by omega mu cross e, that we get from Maxwell's equation. So use that here. So this gives us S is equal to minus 1 by omega mu into E cross K cross E, which is a vector triple product. Now if we expand that vector triple product E cross K cross E, that gives us K into E dot E minus E into K dot E. Again here K dot E is equal to 0 because K and E are orthogonal to each other. So we are left with minus 1 by omega mu into K into E dot E. And now this K being a vector, we can write it as K into K by absolute of K. K by absolute of K gives us the unit vector of K. So that we can write as K into K by absolute of K. So that also we can write as equal, this will be equal to minus root over of epsilon by mu, that we get from 1 by omega mu. 1 by omega mu is equal to root over of epsilon by mu, omega by mu into K. So that gives us this. So, and this into E dot E into K divided by absolute of K. Now left hand side is S, right hand side is this minus root over of epsilon by mu E dot E into K by K, which means S is a vector, K is a vector, but S, if you consider the magnitude, S is equal to, is proportional to minus K. So S and K are two vectors which are anti-parallel, which means S and K are not in the same direction, they are in opposite direction. So this is the difference. Now we have derived this for the double negative material or LHM material, left-handed material. We'll see why it is called left-handed material now. But since these two are opposite in direction, so LHM, S and K are not in the same direction, they are anti-parallel or in opposite direction, whereas in the right-handed medium, they are in the same direction. S and K are in the same direction in normal right-handed material. Now, let us see why the propagation in LHM medium, left-handed medium, is called a backward propagation. So let us compare the two mediums, propagation in the two mediums. DPS medium, which is double positive, both epsilon and mu are positive, and DNG medium, which is double negative, epsilon and mu are negative. Let us consider these two mediums. So let us start with DPS medium. E and H, they form a plane for a plane wave. So E and H are in a plane, and this is propagating, the wave is propagating along S. So S is equal to E cross H, that we know by definition, S is equal to E cross H. So S direction is perpendicular to this. So they form a right-handed triad, therefore it is a right-handed medium. Now what is the K direction? Next. K is along S in DPS medium. So E, H and K, they form a right-handed triad. Therefore the medium is called a right-handed medium, DPS medium or right-handed medium, because E, H and K, they follow the right-handed rule. K is along S and K is perpendicular both to E and H, following a right-handed rule. Its direction is determined in this manner. So next. So this is called a right-handed medium. In this, S and K are parallel, are in the same direction, but the phase velocity and proof velocity are also parallel or in the same direction. and it follows the right-handed rule as you can see. So we call it a right-handed medium also, DPS medium or right-handed medium. Now let us consider the DNG medium. So here also EH are in the DPS medium. So if EH are like that, then S is perpendicular to them. S is equal to E cross H. So this E, H and S, that triad has not changed. But when we consider the K, as we have seen, K is in the opposite direction to S. S is equal to a constant into minus K. So K is in the opposite direction to S. So E, H and K, they form a left-handed triad. Since they form a left-handed triad, the medium is called a left-handed medium. The material in which this is satisfied is called left-handed material or LHM material. Now in this left-handed material, S and K are antiparallel, Vp and Vg are antiparallel. Now since Vp and Vg are antiparallel, therefore the energy flow and group velocity are in the direction, in suppose x direction, then the wave velocity will be in the opposite direction. Wave velocity is the velocity of the is the phase velocity. So phase velocity and group velocity are in opposite direction. Energy flow is along the group velocity, and wave velocity is in the opposite direction. Next. Next. Now, because of this phenomenon, left-handed material, mu is negative, epsilon is negative, n is negative. Because of this, what are the consequences? The consequences are some of the classical physics, some phenomena in classical physics are reversed. What are those phenomena? First is Doppler effect. In Doppler effect, when the source is approaching the observer, then the frequency increase. But if the source is approaching the observer in a DNG material or left-handed material, then the frequency will be decreased. Instead of increasing, it will decrease. So Doppler effect is reversed. Next. Then Cherenkov radiation. In the Cherenkov radiation, what happens is the blue cone that is generated in the Cherenkov radiation, the apex of the blue cone in the right-handed material will be, suppose, in the positive x direction, then the apex will be in the negative x direction in case of left-handed material. So that is, there is a reversal in Cherenkov radiation. Next. Then Snell's law. In this Snell's law, what happens is, if you incident a ray of light or ray in the metamaterial or the DNG material, what will happen is, if it is incidented, suppose in a quadrant 3, we expect, suppose in quadrant 2, then we expect that the refracted wave will come out in quadrant 4. But in DNG material, the refracted wave will come out in quadrant 3. So instead of coming out in quadrant 4, it comes out in quadrant 3. So that there is a reversal in the direction of the wave in the Snell's law. In the lensing effect, because lens depends on the operation of lens, depends on Snell's law. Because of the reversal of Snell's law, lensing effect also is reversed. The converging lens in the double positive material, DPS material, acts like a diverging lens in the DNG material. and the vice versa. Then Gaussian sense effect is also reversed. In this case, when the total internal reflection occurs, that at the point from which the reflection is occurring, that will go towards the interface in case of LHM, whereas it actually in the natural materials or double positive materials, it goes away from the interface. So these are the consequences of left-handed material. The classical physics phenomena are reversed. Next. Now, when these were told by different scientists working in the DNG material, the other scientists also tried to see what is happening, and some objections were raised against the topic of DNG material. Balanyu and his group, they said that the wave refraction in negative index media is always positive, it cannot be negative, which means if you incident the incident wave in the second quadrant, it will always come out in the fourth quadrant. And this is very inhomogeneous, or it is not correct to say that it is coming out in the third quadrant in one of the paper. Then and there were some comments regarding the refraction, negative refraction, which is making a perfect lens. We'll discuss about perfect lens later. But to that effect, there were objections. By who? Then Williams, in his paper in 2001, he said that there are problems with negative refractions and he identified some of the problems. Next. So with that, uh, we will discuss next the answer to these objections, some of these objections, how they were answered. We'll discuss in our next discussion. So next time, don't miss the next discussion. You will get the notification for the next discussion on my YouTube. Don't on my YouTube. Don't miss that. And if you have missed my previous discussions, please go back and see those discussions. Thank you.